Assalamualaikum warahmatullahi wabarakatuh. My name is Nar Ala Nadra binti Yusof. My number is DD220096. We are from Group 5 and we will present about the diaphragm pump. So for me, I will present about the introduction part about the diaphragm pump. So actually, diaphragm pump is a type of positive displacement pump that utilize a flexible membrane known as diaphragm to move and pressurize fluids. Then this design allows diaphragm pump to effectively handle various types of fluids, including gases, liquid, and slurries, making them suitable to use for low pressure and low flow application. So this is the component of the diaphragm pump after overhaul. So there are four main components that we highlight for this presentation. The first one is fluid discharge manifold, which used to facilitate fluid entry and exit from the pump. And then we have fluid suction manifold, also facilitate fluid entry and exit from the pump. And the third one is diaphragm, the flexible membrane that creates the pumping action. And the last one is air chamber, also known as pumping chamber, where the fluid is contained and pressurized. So we will continue the presentation with the advantages of the diaphragm pump. Diaphragm pump are generally more efficient, energy efficient, applying greater force during the forward stroke, which can lead to over-operational costs over time. And then it also a chemical compatibility. They are well suited for pumping corrosive of damaging liquids, as they minimize the risk of the leaks when properly maintained. And then it also versatility pump, because the diaphragm pump can handle a variety of fluids, including those with solids and series, making them applicable in industry like chemical processing, wastewater treatment, and also mining. And then diaphragm pump have low maintenance costs, because with infrequent maintenance needs a long and lifespan, diaphragm pump can be cost effective in the long run. And the last one is pressure handling. They are capable of overcoming standing pressure in the flow line, which is beneficial in certain applications. So the disadvantages of the diaphragm pump. Diaphragm pump have a more complex design with multiple valves, requiring a higher level of technical knowledge for operation and maintenance. Also, they have sensitivity to contaminants. They perform best with clean liquids, and the presence of particles or gases can lead to clogging of check valves, affecting performance and also accuracy. And the fuel pump also have back pressure limitation. This pump do not handle back pressure well and must be set to maximum stroke to prime effectively. And then diaphragm pump have a potential to pulsation. Larger diaphragm pump may experience high pulsation, which can damage piping system unless dampeners are used. And the last one is diaphragm wear. Regular maintenance is necessary to prevent diaphragm failure, which can lead to leaks and also operational issue. So that's all for my part. Then this presentation will continue for the next presenter.
Before I proceed to the presentation, first I introduce myself with the name Muhammad Al Ilmi bin Muhammad Adam and my metric number DD220086. Here I will explain about the diaphragm pump workflow. First, the pump starts in neutral where the diaphragm is at rest. The inlet and outlet valve will be closed and ensure no fluid is displaced initially. The diaphragm will be bent outward away from the pump chamber by mechanical or pneumatic force. This will create a vacuum in the pump chamber and reduce the initial pressure. The low pressure causes the inlet valve to open and allow fluid to begin entering the empty space in the pump. The outlet valve remains closed during this phase to prevent backflow movement. As the diaphragm continues to move outward, it will cause the pump chamber to fill with fluid. Once the chamber is full, the suction stroke and the diaphragm is at its maximum displacement. The diaphragm will begin to move inward, that is toward to the pump chamber due to the reverse mechanical or pneumatic action. They increase the pressure in the chamber simultaneously, forcing the inlet valve to close and preventing the fluid from re-entering the inlet pipe. This increasing pressure causes the outlet valve to open, allowing fluid to flow out of the pump chamber. Lastly, the diaphragm continues to oscillate between the suction and discharge stroke. This cyclic movement will continue to occur to ensure a steady flow of the liquid through the pump.
This is a Wilden PX 1500 76mm 3-inch advanced aluminum pump. The liquid chambers are alternately filled and emptied by fluid that is drawn through a common inlet and discharged through a single outlet. The diaphragms in each chamber are linked by a single shaft, allowing them to move in unison. The air valve directs pressurized air to the back of diaphragm A. This begins chamber B's suction stroke, which starts as diaphragm B is moved toward the center of the pump, thereby creating a vacuum in chamber B. Atmospheric pressure then forces fluid into chamber B past the inlet ball valve. When the pressurized diaphragm A reaches the limit of its discharge stroke, the air valve redirects pressurized air to the back of diaphragm B. This begins the discharge stroke of chamber B. The hydraulic forces developed inside of chamber B force the inlet ball onto its seat and the discharge ball off its seat. This condition allows fluid to flow through the pump discharge. The same process occurs in the opposite chamber, constituting one full cycle. The pump will continue to run until inlet air supply is interrupted or discharge pressure rises to equal that of the air inlet pressure.
Assalamualaikum. My name is Abdul Naif bin Muhammad Zuki. Metric number CD230055. I will continue the presentation about diaphragm pump. Okay, my topic is application of diaphragm pump. So we have two examples of the application diaphragm pump. First is oil and gas and second is water treatment. I will explain first about oil and gas. Diaphragm pump has a variety of function in oil and gas. Their robust design ensure its endurance against harsh conditions. One of its use is a positive displacement pump that works like a valve to draw oil and gas into a refinery chamber during the process upstream and midstream phase of oil refinement. For the function of diaphragm pump in a oil and gas is to transport large volume of liquid and ideal for refineries that are located over sensible oil source, and it is more wear resistant because of having fewer friction that wear down the component. Next is a water treatment plant. Water treatment plant is very important for a community. We want the plant to operate at a maximum efficiency. How does it apply? When the diaphragm pump is open, it uses air or hydraulic fluid in a pressurized environment to force wastewater to move in a specific direction. Choose a water treatment plant. And when the diaphragm pump is closed, it will stop flowing. Okay, the function of diaphragm pump are crucial for dosing and measuring chemical like chlorine, sodium hydrochloride, and other dispensants in water treatment plant. The precise flow control and chemical compatibility make them ideal for clean and to be the water is safe. I will continue to the our member. Thank you.
Assalamualaikum and Bismillahirrahmanirrahim. I am Nur Batisha, ticket number CT230096. We present about the conclusion of diaphragm pump. The conclusion of diaphragm pump is diaphragm pump are an important type of positive displacement pump that allow them to handle a wide range of fluid. This made them an important choice of industries such as water treatment and oil and gas. One of the important advantages of diaphragm pump is their operation versatility. It can efficiently drain fluid under both high and low pressure conditions while being self-priming. In addition, it can operate dry without damage, which is suitable for challenging environment. In terms of energy efficiency, the diaphragm pumps are designed to operate effectively when powered by compressed air. Its construct allows for durability, especially when equipped with suitable materials such as PTFE or EDPM diaphragm. This material provides excellent resistance to chemical and mechanical wear, ensuring a long pump life. Diaphragm pump have several limitations. It is not the best choice for applications that require very high flow rate. Additionally, diaphragm may underachievement wear over time, requiring periodic inspection and maintenance to ensure optimal performance. In conclusion, diaphragm pumps are highly reliable and adaptable equipment for fluid transfer, offering exceptional safety, efficiency, and durability to maximize their performance and extend their lifespan. Regular maintenance and careful selection of material are essential. Their ability to handle device and challenging fluid transfer tasks make them an asset in variety of industry. That's all from me and my group. Thank you for watching.